Hi everyone. I was talking recently with a friend of mine. I'm sure he will recognize himself, but just in case he doesn't, hi Jerry. Jerry is a great guy. He was going around the town looking for a piece of furniture to buy. He visited several furniture stores, and in one furniture store he saw employees use information system like this. And it was quite different from what he saw previously at a particular Swedish furniture store where employees were using information system that looked like this. Of course, it was much easier for employees in Swedish furniture store to give him more details about how his piece of furniture would look like, how it would fit into his room, colors, availability, basically everything. Now, Jerry is a smart guy, and soon he formed a hypothesis in his head stating that service level of a business is directly correlated to the capability and usability of its information system. And Jerry was not wrong. My name is Krnic from Kroz. My colleague Damir and I will tell you a story about a project we recently participated in that dealt with modernization of a 20-year-old monolith. Who are we? Who is Kroz? Kroz is Croatian software consultancy specialized in cloud-native development, complex integrations, data engineering, and supporting our customers build DevOps culture and increase their business agility. The story I told you about these furniture stores reminds me deeply of a project that we proudly participated in, where we had the task of modernizing a 20-year-old monolith system. The goal of the project was to build a completely new user interface for parts of the system and to establish prerequisites for future API economy and breaking the monolith. To give you a bit more context, this is a huge monolith supporting critical business processes dealing with money, regulations, and audits. Technology-wise, we are talking here about IBM mainframe, COBOL, PL1, DB2, and ZOS. The user interface had a typical mainframe look and feel, and the user knew exactly what to expect from such an interface. It was reliable, but the look and feel was obviously a bit outdated, and there are some cool new functionalities that new modern UI frameworks could additionally support, but were of course missing here. In a nutshell, we had to do a number of things. Number one, provide a new user interface to a 20-plus-year-old monolith. We wanted to provide something that would be easier to use and something that could visually give more information to the users. Second thing we wanted to achieve is build a new API layer on top of the monolith. This monolith is a huge one with a lot of functionalities, and it would be foolish and basically impossible to just get rid of it. We wanted to build an API layer around it so all other applications could continue to use its services. This project was not only about super cool new technologies, but also about leveraging existing systems that have a lot of business value. We couldn't and we didn't ignore that. By exposing APIs, we also wanted to build foundations for future API economy. Third thing we wanted to deliver is several completely new business applications. Since we're talking about money, regulations, and audits, the concept of event sourcing naturally came up. With event sourcing, it was much easier to track actions on particular entities and later figure out who did what and how did the entity end up in its current state. Also, we realized that read operations in this system are much more common and that different systems will be looking for different datasets and that they will need fast response. That's why we decided to architecturally separate read operations from less common and much simpler write operations. So this is where the concept of CQRS came in help. And finally, the target runtime environment for our new applications was a private cloud environment based on Red Hat OpenShift. So this is one more moving part that we needed to fit in the picture. We agreed on the following architecture, as you can see in this slide. So what we did here is we put a new facade to isolate the legacy system. So the legacy system, the old monolith, is this blue rectangle symbolizing ZOS. So this is what we call the internal API layer. We wanted a sort of contract here that prescribes what other systems can ask from the legacy system. It also, on the other hand, provided people who maintain the system to freely change the system without fear of breaking the compatibility as long as these interfaces are preserved. On top, we have built a set of new business applications. These business applications are built in microservice fashion using Axon Framework. Here we have put another API layer, the one that we call external API layer. And this one is acting like a real organizational API layer. So this is the foundation for future API economy. New business applications are using this external API layer. Of course, external interfaces do not map directly to these internal interfaces down there, and therefore we needed an integration layer, something to transform interfaces, to orchestrate web service calls, to do some data transformations, and so on. So this is what this integration layer in the middle serves for. Regarding runtime middlewares, this is how it is set up. So on the bottom we have our legacy system based on IBM mainframe. API layers, both internal and externals, are built using IBM API Connect product, while integration layer is built using IBM Integration Bus. New business applications running on Axon Framework are run in container platform, Red Hat OpenShift, and you can see that on the top of the picture. Now tell me, what kind of IT project would this be if we didn't run across some challenges? And of course, we did run across a number of challenges. And I'm happy to report that we have solved all of them, this way or another. And none of them proved to be a showstopper for the project. My colleague Damir now will give us a little bit more technical details on these challenges.
Hi, I'm Damir. I'll try to describe details about small share of challenges that we had. As this was quite a big project, you can imagine that we had many challenges. The vast majority of them were not related to the CQRS and event sourcing or Axon. To mention just a fraction of this, we had to deal with the fast-growing codebase and its organization, with dependency monitoring and management, integration test execution times, etc. There were challenges about optimized Docker image creation, continuous integration pipeline definitions, OpenShift deployments, database migrations, security integrations, delivery mechanisms, fast-changing requirements, and so on. Now that I'm thinking about it, it was quite a long and impressive list, and we dealt with it in one way or another. We are quite happy with some solutions, while others, we believe, are good enough concerning given constraints. As always, of course, there is probably at least some room for improvement. But let's focus on CQRS and event sourcing and Axon. To give you a basic idea about the setup, Axon-based applications use a database as an event store for each bounded context. The project was started before the Axon server was available. Each application implements its own bounded context, while inter-context communication uses IMQP as a messaging protocol for transporting events. As the environment is quite sensible related to the user data, access to the production runtime is pretty much forbidden for external parties. So our primary source to get some insight into how production behaves was logging. Unfortunately, OpenShift had issues with logging reliability at the time, and logging entries were quite often reordered in big chunks. So we needed a way to correlate logging entries from command and event handlers reliably. Of course, such functionality will be beneficial if there aren't any issues with the logging infrastructure. We implemented it by using Axon's handler enhancer definition mechanism. Using some conventions about property names in commands and events, we were able to come up with loggers that can reliably correlate events with commands by leveraging aggregate IDs and event sequence numbers. It is interesting to notice here how Axon and CQRS and event sourcing help in this situation. As we have an asynchronous system, direct causality between commands managed by aggregates and events handled by projections enable their indisputable correlation. Another example of a challenge we faced was a simulation of synchronous responses to the user interface. Axon and CQRS event sourcing systems in general does not give much information about handled commands, at least not by default. And such behavior is by design. Commands provide notification about success or failure, and an aggregate ID of the aggregate instance that handled that specific command. For inquiring additional information, one should go to the query site and ask for details. That way, CQRS protects the implementation details of aggregates and does not expose them to API users, and this is known best practice. However, it opens some questions about communication with API clients, for example, with UI. One way to handle it is by using the WebSocket protocol. Unfortunately, it wasn't used in our environment for various reasons, and quite frankly, as we were already introducing very significant changes, we didn't want to disrupt even more. So we had to handle everything through HTTP. One obvious solution is to implement a client in a way that will issue a request to the query site upon receiving notification from the command side. But there is a problem. What if the projection wasn't finished at the time we asked for it? For this scenario, we implemented polling based on aggregate ID and a sequence number, which are known to the client. Another solution is to break some rules and to return a richer response from command handlers. Deviation from best practices can be softened a bit by exposing aggregate state through DTO objects. On the positive side, latency is significantly reduced, and there is no need for a second request, and there is no waiting for projections. There is another benefit. Imagine that you need to integrate your CQRS system with 20-year-old batches. Can you change them to issue requests on the query side? Maybe, but probably not. As long as you know possible harmful consequences, you might end up using such an approach if you don't have other options left. At the time, Axon was supporting such usage, but not in an elegant way, so we extended it. The latest versions of the Axon Framework includes full support for this, with all warnings and red flags raised. However, these days, especially with the Axon server, there are other options like using subscription queries. If you face described scenarios, make sure to explore them and think about how they can help. As a next challenge example, I will try to explain one that we had in the area of Axon integration with the Spring framework. It is about supporting more convenient auto-wiring capabilities for aggregates. Because of requirements related to loading and serializing aggregate state, Axon has to manage aggregate instances on its own. Aggregate instances are not controlled by Spring. In more complex cases, aggregates can have dependencies that we want to resolve from Spring. The typical best practice pattern is to use constructor injection for supplying dependencies. Unfortunately, this does not play well with snapshotted aggregates, as contained serializers commonly use no-arg constructor for creating instances, and after that, they populate the aggregate state. At the time, it is too late to use another constructor. As there was no easy solution to support constructor injection, Axon settled on resolving dependencies through parameter resolvers. They provide Spring dependencies as method parameters. Since we didn't want to repeat dependencies for each method call, we started exploring the Axon code looking for some workaround. It turns out that Axon already uses Spring for resolving dependencies, but only when loading existing aggregates and only for auto-wired fields. We extended these field auto-wiring capabilities by wrapping Axon repositories in our custom repository to provide field auto-wiring for new aggregate instances too. There is still no support for constructor injection, but we prefer to use field injection than repeat dependencies for each method call. There are some other mechanisms supported by Axon that may be used to get closer to constructor injection, but we didn't explore them at the time since we believed that our solution was good enough. All that I just described, one may consider as primarily stylistic problem. However, as one of the main Axon points is the ease of development and usage, it is not hard to imagine that the Axon team already considered this issue, and there are plans to tackle it in the short term. So I guess we might expect full dependency resolution support, including constructor injection, very soon. Moving to the next challenge. It is about projection reliability. In any CQRS event sourcing system, projections typically deal with turning continuous event stream into eventually consistent database-like views, suitable for efficient querying. But what happens if some particular event causes an error in the projection? If we have some short-lived transient problem, something like a glitch in the database connection, projection can simply retry. In the case of transactional databases, Axon will deal with the problem automatically. But what if the problem is more permanent? For example, what if we have a bug in our projection? Of course, it will not resolve itself just by retrying. We have to fix it. In the meantime, projection is practically blocked because it cannot just ignore failing event and try with the next one. Bugs in handling commands or queries are evident to the user. Although unpleasant, they are typically easy to handle, since they usually do not affect the system state. But bugs in projections are quite different. Queries and commands are working, but new events cannot be projected. Since these events are already stored in the event store, we end up with a half-correct system. Events are there, but their effects cannot become visible. Eventual consistency is gone, and we have an inconsistent system. If you practice continuous delivery, then it might be enough just to fix a bug and deploy the fix. Axon will deliver a failing event to the projection again, and it can recover. Even with continuous delivery, the applicability of the just fix it solution is highly dependent on the details of your domain. It might not work for every case. But what with the more traditional systems, where you need a couple of days, at least, for deploying the new version? Well, you better be sure that your projections do not have bugs. Actually, this is the best solution overall, of course. Therefore, you need to have a comprehensive suite of projection tests. There is no way around it. These tests must cover all event types you have ever had in your system since the first production day. Being aware of projection sensitivity, we created an appropriate suite of integration tests. Nothing revolutionary. But to be even more confident, we also introduced another kind of projection testing, event replay testing. The basic idea is to populate an empty event store with representative samples of each event type you ever had in production. Then tests can verify if projections were successful and that the number of events from the event store corresponds to the number of events handled by each projection. The creation of representative events is a manual process, but it does not take much time if you practice it from the start. As a bonus, the described technique can be very handy for demonstrations, as you can bring the system in any desired state. But still, what if some bug sneaks in? Based on Axon provided APIs and hooks, you can implement a customized way of handling such errors. The exact algorithm is entirely specific to the domain and project environment. It depends on various characteristics, like the granularity of aggregates, the number of users that commonly use the same aggregate instances, the number of requests that can potentially go through erroneous execution paths, the speed of fixes delivery, etc. We created a chained error handlers with different responsibilities. One deals with alerting, to give an early warning to the development and operation teams that something is happening. And the next one handles ignoring failing events after the configurable threshold and saving all available details about these events and related aggregates. Ignoring exceptions is necessary if you want to free tracking processors from trying to handle events indefinitely. Further handling requires some manual actions. An administrator should lock affected aggregate instances, which prevents the receiving of new events. After the bug is fixed and deployed, there is a way to publish corrective administrative events, bringing failing projections into expected state, taking into account all ignored events and their data. After that, affected aggregate instances can be unlocked. The quite involved and semi-automated solution, but it is suitable and good enough for our domain and environment. It is vital and very encouraging to mention that we never had such an incident through 2 years of production, which bring us back to the importance of projection testing. Anyhow, we believe that handling of permanent projection errors in CQRS event sourcing systems is the area that needs more attention and exploration. To my knowledge, the Axon team is also actively researching possible solutions and patterns that might become part of the framework in the future. Again, in the meantime, your best defense is to invest heavily in projection testing. As we just saw, there were quite some things to keep us busy, and I described only a small fraction of them. After we passed the initial production frenzy and stepped into a more composed development rhythm, we had some time to reflect and look back. There were many exciting technologies, challenges, and solutions, and we learned a lot in the process. While thinking about it, somehow we came out with the idea of starting an open source project. For us at Cross, it might be an excellent environment to continue exploring and building based on those previous experiences. We can buy ourselves the chance to improve and grow further, so we can be in better starting position for our future projects. We also believed there might be some potential in a broader context than a single company, since CQRS and event sourcing systems and architecture are still young enough and not so widespread and well known. When we were researching, we felt there is a lack of more complex examples going beyond the basics. With all this in mind, we finally decided to start Project Klokwrk, our open source initiative. It should be useful to us, and it may help others as well. We tried to enumerate several goals that Project Klokwrk should meet at some point in its life cycle. It should be a working example of a complex microservices-based system. It should not be strictly bound to the Axon or CQRS and event sourcing, and should be useful outside of that context. It should be elaborated enough to go far beyond hello world examples. It should demonstrate the usage of well-known application architectures, for example hexagonal architecture, in the CQRS and event sourcing context. It should define an organized and usable structure for multi-module projects. It should provide suitable ground for incubating and developing extensions for third-party libraries. It should encode as much as possible from our previous work and experiences. It should provide an environment for experimentation and research, and so on. Of course, this is not a definitive list. We can easily expand it. Also, special attention is given to testing. Although at the early stages, Project Klokwrk provides usable examples of architectural testing, Docker-based integration testing, component testing, and event replay testing. There is more, and if you are interested, please come to the session about Project Klokwrk tomorrow. There is one more important thing. It is about returning back to the open source community. Quite often, in commercial projects, reporting back to the community is entirely in the developers' hands. They are allowed to do this, commonly, but usually there is no dedicated time in the plans. One of the ideas behind Project Klokwrk is to streamline development efforts as much as possible. As we are using many different open source tools and libraries, it is in our best interest to try to help with the issues we encountered. No matter how small or big they are, we are consistently trying to report them at least. usually after the appropriate debugging effort to make the report more precise and accurate. If we are already familiar with the library internals, we try to suggest possible ways to resolve it or submit a pull request. Often it delays our plans, and we might deviate from expected development progress. But we will continue doing so. We strongly believe it is a worthwhile effort which will simplify our work at the end. For some issues, we will never get a response, but even this is a valuable information hinting you on what you shouldn't rely on. On the other hand, it is very rewarding to encounter friendly and responsive teams and communities, where your invested effort is respected even if you don't know much yet. And Axon team and community is exactly like that. I know it is a bit suspicious when you hear this on Axon Conference, but as an anecdote, I will mention that the Axon team member asked me once to arrange a video call about clarifying one issue. How many times did you hear something like it? I know I didn't. Okay, with these open source stories I will finish. If you want to hear and learn more about Project Klokwrk, you are all invited to the session tomorrow. Thank you.
Thank you, Damir. I also wanted to mention some of the organizational and sociotechnical challenges that we are facing on this project. For example, this was a project that lasted for almost 2 years, and we were working alongside our partner. And at some point, from cross-side, there were something like 50 people involved in the project. So you can imagine delivering so many functionalities with so many people in so many teams, we were bound to hit some obstacles down the road. And lo and behold, the problem soon started to arrive. So the first bottleneck that we encountered was the lack of automation. We were delivering a lot, we were delivering to many environments with many teams, and at the beginning we started doing it manually, knowing that it's not going to be a sustainable solution. And at some point we had to invest in automation. So basically everything that could be automated, we moved to deployment pipelines. And for this, we used Jenkins. Using Jenkins and speeding up the delivery procedure, we removed the bottleneck of lack of automation. The next bottleneck that we encountered was configuration management. We noticed that it became very difficult to manage so many configurations on so many environments, and that we needed some kind of help, some kind of tool. And for this, we used Customize. So just like that, step by step, iteratively, we addressed the biggest obstacles that we found and the most expensive obstacles, the most expensive problems, until we hit the level of automation that we were really comfortable with. Another thing that we also realized on a project of this size is the need for having a platform team. So if you are familiar with the ideas described in the book Team Topologies, there are 4 basic types of teams in any organization. So those are feature or streamline teams, enabling teams, complicated subsystem teams, and platform teams. The role of a platform team is to build and maintain a platform that other teams will use while delivering value to the end users. In that sense, platform team has its own users, and those are actually other teams. And the product of a platform team is the platform itself, ideally a self-service one. Platform team should be in close contact with other teams. It should ask for feedback on the platform and look for the way to enhance developer experience. In a project this large, you simply need to have the owner of the platform, somebody who would define standards and somebody who would take care of the whole platform. I mean, we were using here Red Hat OpenShift, API Connect, Integration Bus. We were using a host of automation tools, and this is a lot of moving parts, and it becomes impossible for a single person to both develop software and to take care of all the details of the platform. The cognitive load on that person is just too high. So, as Matthew and Manuel wrote in the book, the purpose of a platform team is to enable streamlined teams to deliver work with substantial autonomy. The feature team or the stream-aligned team maintains full ownership of building, running, and fixing their application in production. But the platform team provides internal services to reduce the cognitive load that would be required from stream-aligned teams to develop these underlying services. Needless to say, when we formed the platform team, the needle started to move in the right direction. The platform became more stable and feature teams could focus on what they really do well, and that is delivering value functionalities to the end users. The third thing we practice on this large project is the discipline of chaos engineering. And by chaos engineering, I mean deliberately introducing instability and network volatility to the system in a controlled environment to provoke errors. And we can learn a lot from these errors. There are many benefits. Apart from those technical benefits of solving the bug itself, this practice truly revealed how we as an organization address those issues. So, do we ignore them? Do we just fix them? Or do we truly solve them in a way that we understand how they came about and what do we as an organization learn to prevent them in the future? And from technical perspective, we use tools such as test containers and toxic proxy. And from organizational point of view, we use standard facilitation techniques of retrospective to learn from errors and do better next time. Other organizational challenges include, I would say, traditional challenges of connecting business and technical people to foster an environment where everybody works together toward a common goal and toward delivering value to the end users. But this is completely another story. A lot of these concepts are integral part of DevOps culture, and we talk about this topic extensively, especially through our newsletter called 0800 DevOps. So I encourage you to take a look at it. This is the URL, and subscribe. To wrap things up, this was truly a challenging project, and we learned a lot. And what is most important, we delivered actual value to the end users. Thank you all for being here, and I hope to see you all at our Klokwrk workshop. Thank you once more.